It is 4 in the morning. You have been awake since yesterday. The coffee stopped working 2 hours ago, but you are still staring at the screen, telling yourself you just need to push through a little more. Your eyes feel like sandpaper. Your thoughts are arriving in fragments, each one taking a half-second longer than usual to fully form. And somewhere in the back of your mind, a vague anxiety is building, though you can't quite locate what it's about or why it feels so heavy. What is actually happening inside your skull right now is not simply tiredness. It is not your body running low on fuel the way a car runs low on gas. By the time you hit 24 hours without sleep, your brain is in the middle of a biochemical emergency, a cascade of neurological failures that progresses with unsettling precision, hour by hour, affecting systems you rely on for judgment, emotion, perception, and physical survival. And the most alarming part is not how it feels. It's how thoroughly it distorts your ability to detect that something is wrong. By the end of this video, you will understand exactly what is shutting down in your brain as the hours accumulate, and the mechanism behind it reveals something about what sleep actually is that will change how you think about every night you choose to cut it short. Most people treat all-nighters like a calculated trade-off. You sacrifice tonight's sleep to gain tomorrow's productivity, and you pay back the debt with a longer sleep the next day. You feel the cost in the morning, the grogginess, the dragging pace, but you recover, and the logic seems to balance out. This intuition is so deeply embedded in how we think about sleep that entire cultures of work and achievement are built around it. The badge of honor worn by people who routinely sacrifice sleep as a demonstration of commitment. But this intuition rests on a fundamental misunderstanding of what sleep actually is, and that misunderstanding has measurable, documented consequences. If you want to keep understanding the biology behind what your body is silently doing and silently suffering from, this channel exists to make that science accessible without the textbooks. Subscribe now, because what comes next in this video is the kind of thing you should have been taught a long time ago. The starting point is a molecule your brain produces every single second you are awake. It is called adenosine, and it is one of the primary byproducts of the metabolic activity that keeps your neurons running. Think of adenosine as the metabolic exhaust of thinking. As your neurons fire, processing input, forming thoughts, making decisions, adenosine accumulates in the spaces between them and progressively binds to receptors that slow down your brain's activating systems. The longer you stay awake, the more adenosine builds up, and the heavier what sleep scientists call sleep pressure becomes. It is a precise, chemical, accumulating demand for unconsciousness. When you drink coffee, the caffeine molecule temporarily blocks adenosine receptors. It doesn't remove the adenosine. The chemical exhaust is still accumulating. Your brain just loses the ability to feel it for a few hours. This is why caffeine stops working after a certain point in an all-nighter. The adenosine load becomes so heavy that even receptor blockade can't mask it. And it is why the crash hits so hard when caffeine wears off. All that accumulated pressure lands at once. By the time you reach the 16-hour mark of continuous wakefulness, functional changes in your cognition are measurable. Even if you don't subjectively feel impaired, reaction time has slowed. Working memory has started to degrade. The prefrontal cortex, the region of the brain responsible for planning, reasoning, impulse control, and weighing consequences, is beginning to function less efficiently, and its communication with the amygdala, your brain's emotional alarm system, is starting to decouple. Under normal conditions, the prefrontal cortex acts as a regulating hand on the amygdala, moderating your emotional responses so they remain proportionate and contextually appropriate. As sleep deprivation deepens, that regulating hand loosens its grip. This is the part that most people don't feel coming, because the change is not a sensation of tiredness. It is a change in how you interpret reality. Research using functional neuroimaging has shown that the sleep-deprived amygdala becomes up to 60% more reactive to negative stimuli than a rested one. Small frustrations feel disproportionately large. A mildly irritating email reads as a personal attack. A brief moment of uncertainty spirals into catastrophizing. You do not feel like your emotional responses have changed, which is exactly what makes it dangerous. You feel like your responses are appropriate, because your prefrontal cortex no longer has the resources to evaluate them critically. You have lost the judge, while the courtroom keeps running. At the 24-hour mark, something even more striking appears in the data. A study published in the journal Occupational and Environmental Medicine compared the cognitive performance of sleep-deprived subjects with subjects who were legally intoxicated. Blood alcohol concentration of 0.10%, above the legal limit for driving in most countries. On every measured metric, reaction time, decision-making accuracy, attention, motor control, the 24-hour sleep-deprived subjects performed at a level equivalent to or worse than the drunk ones. Yet, in the same study, the sleep-deprived subjects, when asked to evaluate their own performance, consistently rated themselves as capable and functional. The intoxicated subjects knew they were impaired. The sleepless ones did not. Share this with someone who tells you they function fine on no sleep, because the data says they are the last person equipped to make that judgment. Now here is where the biology moves from concerning to genuinely unsettling. Your brain has a defense mechanism for extreme sleep deprivation. A last resort protocol it deploys when the pressure becomes critical. It is called microsleep. Microsleeps are sudden, uncontrollable episodes of unconsciousness that can last anywhere from a fraction of a second to about 4 seconds. They can occur with your eyes open. You can be mid-sentence, mid-task, or staring directly at the road ahead of you. During a microsleep, your brain has taken local regions of the cortex offline. The neurons have stopped responding to external input and entered a sleep-like state, while other parts of you continue to look awake from the outside. You experience a jump cut in time. You were here, and now a moment has passed, and you have no memory of it. People who study microsleep in driving simulators report that participants who experience them often have no idea they occurred. The brain suppresses the awareness of the gap. You cannot feel yourself having a microsleep any more than you can feel yourself falling asleep at night. That is the point. The brain has stopped asking for permission. It is taking the sleep it needs one fragmented second at a time, whether or not you are operating heavy machinery. What all of this reveals, the adenosine buildup, the amygdala hyperreactivity, the impaired self-assessment, the microsleeps, is that sleep is not the passive absence of wakefulness. It is an active biological state with specific, non-negotiable functions. Functions that cannot be compressed, skipped, or adequately compensated by catching up later. The scientific consensus, built across decades of sleep research at institutions including Harvard Medical School and the University of California, Berkeley, is that chronic sleep debt accumulates neurologically in ways that a single recovery night does not fully reverse. The brain keeps a ledger, and the debt compounds. Understanding this changes the calculation. Every hour of sleep you sacrifice is not a neutral trade-off. It is a direct withdrawal from the resources your brain needs to process emotion, make sound decisions, maintain physical health, and, when it becomes acute, keep you physically conscious in the places and moments where that matters most. Have you ever noticed how the world starts to feel slightly unreal after a long night without sleep? That strange, detached quality where everything looks almost normal but something feels off? Tell me in the comments what your personal limit is, the number of hours where you start to feel genuinely impaired, and whether knowing the biology of it changes how you see it. We treat sleep deprivation like a tax we pay for ambition, but neurochemically, it is not a tax. It is a fire sale, selling off biological capital that was never meant to be traded.